let's look at this. From the question, it gave you the power transmission model, and you can see this is the voltage, this is the voltage, this is voltage, these are the numbers that you need. Part A suggests one possible way of storing the surplus energy. That means after you have the power station, let's say hydroelectric, fossil fuel power station, you kind of gain the energy, right? And how you can store them up. And you could use, I think battery is good enough for you. I guess in the past, there was a part in the syllabus that was cut right now, and you haven't learned that. Anyone got the idea? It works out with C.
Cell.
Cell, close, but cell is basically battery. It's another device. Any ideas? CA. Okay, if you didn't know, if you don't know, that's fine. It's something called capacitor. Capacitor, sorry, no capacitor. Capacitor. OR, capacitor. But don't worry, you don't need to know in this syllabus. We don't have time to cover this part. It's more like a tiny, small battery. You can charge it and discharge it. Part B. Why electrical energy is transmitted in high voltage? Less energy lost. I think we can write more. I guess you understand the idea, but I would say I will prefer to write reduce energy loss or power loss, energy loss, energy loss or wasted in where? In the cables, very good, in the power cables. Yeah, because no one would want any energy in the power cables wasted.
Can we say
Reduce current? No.
reducing current, no.
But yeah, at the end, this is ultimate goal. Because reduce current is the method, but not the goal. Part C. Write down the formula that gives the power loss. So I squared R will be good in terms of R. Yeah, so that's the only equation you can write. Part D. A cell transformer has 1200 turns in the primary coil. And use that to calculate blah 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 step up transformer. So we look at this one. So it turned from 1100 to 32000. So you just need to write down the equation correctly. 32000, that one is in the secondary. So put N2 over here. 100 is the N1, is a primary coil. So I would say I'll usually do this as well, just to make sure you are in the same position. The one at the top, the one at the bottom are aligned. I think this one is crossed out, right? Nothing here. Just N2 over N1. At the end, you'll find out, is that this number?
Yeah.
Is it? Is it the same number?
Yes.
Okay, I trust you. I haven't got the calculator, but yeah, I think so. It should be greater. It should be greater because higher voltage, more coils. Just a number a bit weird to me. E. It said the input of the step-up transformer is this one. Use this value to calculate the current in the cable, assuming it's 100% efficient. So don't worry, that is always 100% efficient in IGCSE. So that's why it should be quite easy. That you should start with VI equal to VI 1 and 2. So on the side where you know the input is 800,000, so I guess put that 800,000, which is good. On the other side, because we know the voltage is 32,000. 30, 1, 2, 3. A bit messy here, but I hope you did it right. 30 here and times I. Is the answer 25? Yeah, so just calculate, use your calculator to find out. Make sure you write down the equation VI equals to VI. Or input power equal to output power. That will be good. Should be quite simple. Yeah? Anna, can you help me to pause and start this video?